I want to join the Million Crater Challenge. And for those of you who don't know what this is, it's a project to get as many people engaged in doing science as we can and to work on illuminating our understanding of the moon. Now, originally, we were going to close this down on May 5th, but we had problems with the server CosmoQuest lives on was actually having a hardware glitch. I just turned on a brand new server. You may notice some of the typos on the site came back when I turned on the new server. I'm very sorry about that. But I don't know if we're going to hit 1 million. I think this is going to be sort of like the million-man marches on Washington, where a million translates into a few 100,000. But we'll keep this full moon meter up to see how long it does take for us to hit 1 million craters. And the easiest way I know to try and get to 1 million craters is to use man versus machine. And this is software that shows you how bad computers are at trying to identify well, anything on the moon. So in this particular image that I just opened up, I don't know if you can make it out. Let me see if I can zoom in on this. Yeah, I can zoom in. So what you might be able to make out is this is an image with a whole bunch of craters on it. And there are 2 lone little tiny blue circles. Those 2 lone little tiny blue circles are craters identified by a computer algorithm. And the image is filled with a ton of other craters that don't have little blue circles. And those are all craters that the software completely failed to be able to identify. And this is unfortunately one of the realities we deal with when we're trying to get software to identify things on the moon for us. The software gets confused when the sun is in a different position than normal. The software gets confused when the terrain is a different color than normal. The software gets confused because, well, it's software and it can do that. And so we as humans have to go in and correct the software. And this is where Moon Mapper's man versus machine stuff is so important, because now I can come in and I can just mark craters. And that one's too small. When the circle is red, that means your circle isn't big enough. We only care about craters that are about 9 meters across or larger. And so when you're marking something smaller than 9 meters, like if I tried to mark that, I have a red circle beneath until it gets big enough, but that's not actually the size of the crater. So do you guys have any questions about the moon or anything? Because otherwise I'm going to end up just sort of aimlessly chattering at the interface with you sitting there, and that's kind of boring. So I'm going to actually bring you over to partially cover the interface on my screen, but luckily no one else sees you doing that. And ask you, what do you think? Do you have any questions? You have a captive astronomer. So what are the types of things you're normally doing when you're doing citizen science?
Well, do you mean on like the moon mappers?
Yeah, yeah. I mean, so like the most of the time when I'm doing moon mappers, I'm sitting on the sofa and my husband's watching TV, and I'm sort of watching TV, but what I'm actually doing is marking craters.
Normally trying to put off doing something else that I should be doing.
So it's your mechanism of procrastination is what you're saying.
Yeah.
What about you, David?
I've got, like you do, a multi-monitor setup. So I've usually got at least 4 things going on at any given time. At least one ICE investigators window going.
That's awesome. Yeah, it's frustrating that ICE investigators is another one of the ones where computers just can't deal with the fact that basically the conditions in the sky vary so much that the software just can't identify KBOs. Now, what's kind of amazing in the image I'm looking at right now is the computer totally didn't mark most of the things correctly. I actually have no clue what it was marking, which is kind of confusing. So is there any chance you're also marking things while we're in this hangout?
I am.
It's funny how addicting it can be.
Yeah, I just get sometimes a bit afraid that I'm doing it completely wrong and just messing time up completely.
Well, that's actually something you shouldn't worry about, because one of the things that we do is we give every image out to at least 15 people. And what we're actually looking for is the times, and I'll try and bring up the gallery in a second. What we're trying to identify is all the objects that get marked by a whole bunch of different people. And what we do is we know some people are going to mark things a little bit small, some people are going to mark things a little bit large, some people are going to tend to mark everything off and to the left. That's what I tend to do. And we take all those different markings and we combine them together. And it's only when a bunch of different people have all marked the same thing that we believe the result. Now, the problem I run into is it's so addicting that like right now I'm like, I want to show them the gallery, but I want to mark this image, but I want to show them the gallery. So I'm going to actually just open up the gallery in a new window. So one of the things that you can do is come into the gallery and click on an image. That one looks pretty. And actually, there we go. So clicking on an image brings it up. And I can see my marks on it, but then what I can do is I can show the averaged marks, and this is the result of a bunch of different people marking this. And then I can show all the individual marks. And when you look at all the individual marks, you can see they're kind of all over the place. But when you average them out, you end up with these really nice, well-defined borders. And it's because as a team, we do so much better than we do as individuals. Now, we still make mistakes. Like this crater in the upper left. This is a very degraded crater, so I can't actually show you my mouse the way this is screen sharing. So there's this bright white crater on the left. And then when I do show my marks, you can see there's this giant crater kind of top center. And I'm going to turn the markings back off, and that crater is really hard to see. So some people, they only marked it where the darkest part of the shadow was. Some people went all the way out to the edge of the rim. So when I turn on everybody's markings, it's kind of all over the place. But when I look at the average markings, sorry, that was the wrong button. When I look at the average markings, I can see the two different choices that people made. So that one's kind of problematic. We'll have to clean that one up by hand. But all these other craters in the image, those are all perfect. And so it's by all of us working together, 15 different people all viewing this image, that we figure out what the truth is. And some people are going to screw up, but together we're going to get it right. And that's what's awesome about this software. So does that help you feel a little bit better about what you're doing?
Yeah. Thank you.
Oh, you're welcome. I'm going to look and see if there's anyone else who wants to join us in here. It looks like I have one more notification. 2 more notifications. Cool. Oh, okay. AstroThad, I see that you're requesting to join the Hangout. You need to send me a link to your profile. I'm going to respond to this. So in order to get into this Hangout, go to the CosmoQuest forums, and there's a thread up at the top, and you can either join the thread and leave me a link to your Google Plus profile, or private message me. I'm Starstrider on CosmoQuest. Private message me a link to your profile. And the reason I'm asking for the link to the profile is one of the things I found in the past is there's like 40 people who all have the exact same name, and I can't figure out which one it is that I need to add. But if you send me a direct link to your profile, I add you to a circle, and I invite the circle, and it's all just really easy. So, Thad, can you please send me, send has 4 letters, send me a link to your Google Plus profile. It's funny how typing, even when no one can see what you're typing, becomes so much harder when you know there's an audience.
I don't know if you saw Neil deGrasse Tyson's tweet about the SuperMoon, saying it's just what a 16-inch pizza is to a 15-inch one. I thought that was really funny.
And that's pretty much true. The difference between a normal moon and a supermoon is it's about 12%. So yeah, it's a 10-inch to 11.2-inch pizza is numerically correct scale as you need to. 10% is a fairly significant difference when you're looking at something. You can actually, if you do the whole hold your finger out at arm's length, see what that is on the normal night, and then compare it to the supermoon, you can actually see the difference. But it's not a big deal. Okay, Sarah, you sent me, I'm reading through the things on the forums. I see that you sent me your email address, which is awesome, but can you please send me a direct link to your Google Plus profile? So the problem with sending me your email address and asking me to use that to add you is Google Plus doesn't actually let you search on people's email addresses, at least not that I've found. And so when you have a simple name like Sarah, and I'm not going to say your last name on this, I can't figure out which of the many you are. Okay, here we go. There we go. Sarah caught on. Thank you, Sarah. You're awesome. So I'm about to add Sarah to the circle. So what's going on is the process for getting someone into a Hangout like this is what I do is attempt to go to their profile page, watching my email become sad as I do it. There we go. And then the person that I'm going to add, I have a circle just for CosmoQuest members. And so I'm going to add Sarah to the CosmoQuest circle. And now what I can do is go, and I have an invite button, and I'm going to invite the circle I just added her to. And so she should get an invite in just a moment. And I'm going to keep looking in the forums to see if there's anyone else who wanted to be added. So you all know now just how easy it is to get in here. And there's Thad sending me a link too, so we'll have him here in a moment. He has like the coolest name. So what are you guys' thoughts on the craziness that is the supermoon mayhem? I know it's been on all the news around here, and when you see MSNBC telling people about the supermoon, you know it's gone mainstream. Are people
it's just people panicking about something that's really not an issue, I think. I mean, it could get a lot of people interested in astronomy and physics, but obviously when it's just like going around the internet like this, it's just going to cause panic, which is unnecessary.
Yeah, it's kind of frustrating. But at the same time, it's cool that there's so many scientists who are using this to try and educate people. So you saw Neil deGrasse Tyson's tweet. I know Phil Plait has had a bunch of different BA facts out about this. What's been your favorite thing that you've seen so far, David? Oh, you're muted again.
I like following the discussion boards on it, like Bridget mentioned. It's interesting to see people freak out, but anything that gets them into science, I think, is a good thing. Anything that gets some publicity for it. And the moon looks really interesting right now, but anybody with a good telescope or a good camera or good Google skills has seen some better pictures of it.
No, that's true.
I'm just going to run downstairs and see if it's visible. I'll take my laptop with me.
So all it takes is a pair of binoculars to get a better view. Heck, all it takes is basically holding any lens up and you get a better view if you hold it the right distance from your eye. But I appreciate anything that makes people think, even if they're thinking entirely wrongly. Because when someone says something stupid, that's an opening opportunity to get them talking. anytime someone has said, well, the best way to do something is X, and you're like, no. But then you can explain to them, and so it's a chance to get dialogue going.
Yeah,
have you actually dealt with any crazies face-to-face on this one?
Say that again?
Have you dealt with any crazy people face-to-face on this one?
Oh, yes. At my work, we have a lot of people that any internet hype is a good reason to freak out. Like you said, anything that gets the dialogue going, you know, you can impart some learning, some knowledge there.
So are you going to get to be able to see it, do you think? What's your weather looking like? I'm checking mine. I luckily don't have to go outside. I just have to open the blinds.
Our weather here is typical Arizona, 0% humidity and clear skies.
Oh, that's awesome and terrible all at once. We unfortunately are typical Illinois weather, 80% humidity and haze, 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 threatening thunderstorms, but hopefully not threatening tornadoes tonight.
Ooh.
Well, I'm fairly good where I live because the tornadoes like to go either north of us or south of us, and we just get the amazing lightning storms. And so far this year, we haven't had any damage around us. We've just had the alarms go off a few times.
Yeah, we get thunderstorms coming through here. It's pretty impressive sometimes. In the last 2 years, we've had sandstorms coming through here, which is actually pretty new for me, having been here 30 years. You know, we used to have giant, giant sandstorms, but they're fun. Just don't drive in them.
One of the problems we have is things like hail. They remove your roof and things like that. Does the sandstorms etch your car paint or anything horrible like that?
Not usually that I've seen. We do sometimes get hail. We had some 2 years ago that made for lots of insurance claims. And then we get what they call microbursts here, which is kind of a very localized downstream of wind. And that can take a roof off pretty quick. It's usually just like one house, which is, you know, having seen tornado damage and stuff, it's interesting to see something so localized.
Yeah, there was one time in Boston, we had a microburst in Boston of all the crazy things. And for those of you who don't know what microbursts are, it's basically everything involved in a tornado generating storm except for the tornado. And so you'll end up with these massive, extremely localized, like half a city block sometimes, downbursts of rain, hail, gusty winds. And I got on the subway at Harvard, which is in Cambridge, Massachusetts, got off 2 stops later in Davis Square, and there were massive damage from tree limbs and everything else. And nothing happened in Harvard, but Davis Square just got nailed by this small microburst, ripped awnings off of things. And yeah, weather can get pretty frightening. But it is what it is, and we keep going, and this is where I love working on internet-based projects, because I can be marking craters on the moon right now, and I don't need to worry about whether or not I can actually see the moon, which is pretty good because it looks like I'm going to get hazed out. So how's your weather going, Bridget?
Yeah, horizon's completely pink, basically.
Oh no.
So
frustrating.
Yeah.
Oh well. Are Olympic fever effects starting to cause like party lights, Christmas tree lights, or anything like that makes the already bad situation worse?
No. Well, I'm looking sort of south here, so it's okay. The Olympics are off to the east, so it's
okay.
Yeah.
So you only have a few more weeks.
You can kind of see what that's my telescope there. I don't know if you can see that, but I saw the moon through that, and that was amazing.
So that's about a 6-inch telescope?
Yeah. I haven't had much time to use it because I've got exams coming up, so.
Okay. It's still awesome that you have it. Do you have a balcony that you can go out on to use it?
No, but there's a playing field behind me, so it's really awesome.
Okay, so that gets you deep down to the horizon then.
Aside from the trees.
Trees happen. That's really cool. So do you have a telescope, David?
I do not have a telescope. I tend to use my DSLR and larger lenses for that instead.
Now, when you say larger lenses, you actually mean some pretty large lenses, don't you?
I have, my largest would be an 800 millimeter. So
That's the size of a small telescope.
it's about as large as you can go without getting into the tens of thousands of dollars for a lens.
That's pretty awesome. So I'm now looking out at the comment feed where it's a Desolava, I can't say this poor person's name, so I'm simply going to apologize. I can't see the picture well enough. This person whose name I'm going to mispronounce, woman, okay, I've zoomed in. This friendly woman sounds like she's in, of course the weather in Spain is nice. I'm trying to figure out where she is. Sounds like she's in the Netherlands suffering from bad weather. Jenny Luca is saying that the weather's been so-so in Zaragoza. I have to admit, I'm not at all sure where that is. So if you could tell us where it is, I'd love to hear. So she's getting to see the moon. Juka is saying the weather's great in Finland. Was great. Now it's all clouded up. But Juka managed to get one picture. My frustration is I really, really, really wanted to get an image of the rising moon, and there's a farm nearby that lets me go up their driveway, and the moon would have been rising right over a red barn off in the distance, and it's like quintessential American red barn, and it looks like I'm not going to be able to get that photo this month. So it'll be another month, and the moon will be 10% smaller, but that will be fine. So it looks like, Thad, you were able to join us. Now, where on the planet are you joining us from?
I'm in Los Angeles. So it's typical Los Angeles weather today, really gorgeous. Still have about another 3 hours to sunset or so.
Yeah.
But, I've got a pair of 25 magnification, 100 millimeter binoculars. I'll see about doing some sidewalk astronomy with tonight and see if we can get some people some views of it. So.
That's awesome. Are you going to try and talk to people about the supermoon?
So yeah, I mean, of course, you get all of the superstitions and all the kind of bad information that goes around with this. I'm sure people will, well, is there going to be an earthquake? No more chance of that than usual. But just that it's really only 7% bigger in diameter than an average. I think that's
it's supposed to be 12% bigger than average.
Okay.
But it's the difference between 10 inches and 11.2 inches. So
right.
It's fine.
So yeah, so I mean, not really anything detectable to the naked eye. If you were taking photographs and had something where you could measure pixels, okay, sure, then you would have some sort of comparison. But yeah, in general, no, nothing really majorly different there. So
what's the craziest misconception that you've heard so far?
I'm trying to think of something my students would have come up with. There was a lot more hubbub about the one back, was it March
19th last year.
Yeah, there were a lot more questions about that one then. I think it might actually be old hat at this point. You get one round of hysteria, and then people kind of settle down. I think the earthquakes one was, of course, the biggest one at that point, though. So.
Well, the thing that made so many people freak out last year is the supermoon was just a few days after the horrific tsunami that affected Japan so badly.
Right.
And a lot of people didn't understand that the moon orbits rapidly enough that when the supermoon occurred, being several days later, meant that if this was the Earth on the day of the tsunami, if the moon was going to be here for the supermoon, it was probably over here somewhere the day of the tsunami. And so it had a good distance to go before it got to that supermoon. And this is Scott Lewis. Welcome to join us. We're just talking about the crazy problems that we've heard about with the supermoon, and I have moon mappers open, and I'm hoping all the rest of you have moon mappers open as well and are doing science with us, taking advantage of the supermoon to hopefully try and do some super science.
I just found something ridiculous. So it's kind of like, I was Googling supermoon and I found this headline on a newspaper we have here. Is the Japanese earthquake the latest disaster to have been caused by a supermoon?
Yeah, that was one of the things that lots of people were in hysterics about last year. And no, it wasn't. It was a horrific coincidence, and that's all it really was this absolutely horrific coincidence. And it's people screwing up as badly as the crater finding algorithm screwed up on the image I'm currently classifying. So I'll bring this up so others can see how bad this is. This is why we need your help. People are always asking me when I tell them about moon mappers, why can't we just program a computer to do it? Well, because computers, pardon my language, computers suck at it. So for some reason, sometimes they just go mad and they decide that the albedo features were actually craters. So the one I just deleted, there's a whole bunch of, it selected these nice, flat, slightly darker regions as craters, and then missed all these actual craters that just are littering this image. And we can write software that does really well for one small region of the moon, and then the second we set it loose on other data sets, it just gives up and does stupid things.
How do you view the marking done by the computer?
So what I'm using is, there's two different tasks in Moon Mappers. So if you go to the Moon Mappers homepage, it looks like this, and you have three options. There's simply craters at the top. And when you do simply craters, right now it's giving you fairly boring areas on the moon. So there's some nice wavy terrain. And what's neat is this wavy terrain, like in this image, we think that that was caused by the moon just getting hit so many times by asteroids that every time it's like shaking it a little bit, and it ends up creating these wavy surfaces all over the moon. But in this particular image, all the craters I have to mark are kind of boring. I'm going to guess that that's actually an eroded crater. But it's called simply craters because it's simply me and the machine staring blankly at one another, and the machine is waiting for me to do all of the markings. Now, if instead I come out and I go to man versus machine, the machine says, I'm going to find all the craters. And in this case, it found one. One lone sad crater in this image. It's up and to the left for those of you who are having trouble spotting it. So it's called man versus machine because the idea is it's pitting my thinking versus the computer's thinking. There's not really much competition going on here. The computer is consistently showing me how bad it is. And now I get to follow up and mark all the things that the computer missed and mock it publicly, as the case may be. Luckily, software algorithms don't have emotions that I can hurt. So I feel perfectly all right mocking the computer for its inability. Now, the reason I'm using man versus machine is for two reasons. When the computer gets it right, it makes it easy to just fly through the images. And when the computer gets it wrong, me sitting here and marking all of the things the computers did wrong helps us improve those algorithms later. Now, the question that we don't know, which is the reason we have the two different interfaces, is we don't know if it's simply faster to let a whole bunch of humans mark craters and just leave the computer out of the entire process. Let the computer go be dumb on its own and mark things badly, or not, as the case may be, and simply ask all of you to go through and mark craters. It may be faster to just let you do all of the work. I don't think so. I think it may actually be faster to let the computer do its thing and then have humans fix the output. But since we don't know the answer, we're running the experiment. We're asking you to either mark the craters completely by yourself or to fix the output of the computer software, mock it freely. It doesn't care. And in either case, the science question that we're answering right now is what are the absolute best conditions for identifying craters? So as you go through the images, what you're going to find is the sun, which is this little yellow symbol that you see at the top of the image, it migrates all over the place. So you'll see it rotating around the image. And that's because we're trying to figure out where is the best place in the image for the sun to be in order for you and the computer to both be able to find craters. We're also trying to figure out what is the fastest way to do it, and we're trying to figure out if different terrains actually need the sun to be in a slightly different place. So if I'm looking at a terrain that has a whole bunch of waves on it, do I need the sun in a different place than if I'm looking at some completely blasted smooth terrain like the one in this image? So we have a whole bunch of questions just about how to find craters that we're trying to get your help answering. And then once we've identified all the craters, one of the things that we're hopefully going to be launching in the next month or so, we need to finish getting everything done for ice investigators first, is if you go into the gallery, which I've done here, what I'm showing right now is the averaged crater markings. So if I show all the different circles for all the different people, 15 different people who've looked at the image, it's all kind of a mess. But we do have software that can take all those different markings and average them and identify where the craters really are. So what we're going to do with these average markings is we're working on what we're calling a crater degradation tool, which is going to be a simple image that shows you one of these craters that we now know exists because of everyone out there working on this. And there's going to be 4 buttons. The first button is perfect crater, and it shows a picture of a perfect crater. The 4th button is, wow, is there really a crater there? And it shows you this hideous, hard-to-spot crater like the one at the top of this image or down on the bottom right of this image. And in between will be the different, basically, erosion states of craters. So the next thing we're going to have you do is help us identify all the different erosion states of the craters. And that's going to lead to an entirely new type of crater map than has ever existed for the moon. And that's actually going to be really interesting information because it allows us to start identifying younger craters based both on younger craters have these white ejecta blankets around them like the one on the left-hand side of this image. But they also tend to be perfect looking. Well, it's easy to flag all of the ones that have white ejecta blankets around them. Those just snap out of the images at you. But finding all of the pristine ones is an annoying, time-consuming task, unless you have 10,000, 100,000, a million people to help you do it. And so that's what we're going to do, is we're going to ask all of you to help us. So I've been blathering a while. Go ahead. What were you going to say, Bridget?
Could you not sort of run the computer behind the scenes and say, give people one image and then have a computer that's maxed it side by side, and then use what's done by people and what's done by the computer to compare, and then fix the algorithm using that?
So the thing about computers is you need to give them so much data to train them that what we're actually going to do is this is a multi-step process. So the algorithm right now that we're using that allows me to show averaged markings, the one that was used to produce this is a preliminary algorithm. We just finished developing this week a brand new, much more complicated algorithm. Did my video freeze on both screens? It did. Hello, unfreeze. Okay, everyone's now moving. Apparently I simply needed to tell it to unfreeze. We just finished doing a much more sophisticated crater averaging clustering code. We're going to be running that, and it actually takes it a few days to go through all of the markings and combine them. But it would have taken a single scientist 6 months to go through and mark everything, so we're fine with our software taking 3 days. once we're done with that, then yes, we can start training new software. So it's an iterative process, and our eventual goal is to indeed train the computers to be better. We just don't know how hard that's going to be, so we are working on that. But what's awesome is while we work on the software, we can work on the science first. It's two different sets of people that work on the software and the science. So we can have both going at once, and we can get awesome science out of the things all of you guys are marking in Moon Mappers, and then get the awesome computer algorithms later that will save us as we start to explore more and more worlds, save us from having to spend so much time marking things.
I just think it's fun after all that it's like a post-enlightenment cartography that we're going into this new world, and we need to map it. We need to know exactly what's up there. And so we might not be Columbus and everyone that went through trying to map this unseen place before, because we've seen the moon throughout all of man, but now we're actually able to see it and map precisely where it's at, which is just awesome at the end of the day.
What really amazes me is the scale of the images. So not all the images in Moon Mappers are full res, because we want to be able to mark big craters as well as small craters. So some of the images are zoomed out a little bit. But the full res images have a resolution such that if a guy who is 6 foot tall lay down on the moon and assumed the snow angel position, we'd be able to see that person as a couple pixels across and several pixels long. And just the fact that these images could see the snow angel dude on the moon is, I think, the coolest thing ever. There's a Google Lunar X Prize to get a robot to the moon, and you win the prize if you get the robot to the moon and the robot roves. I don't know if he's going to walk or wheel. I suspect wheel, but it would be so much cooler if it was one of those Sony walking robots. The robot has to get 500 meters across the moon and then send video back to the Earth. Well, just imagine this will never happen. This is my happy little fantasy world. But imagine, if you will, that it's one of the Sony walking, talking, dancing robots that you see the videos of, or the robots boogie. Imagine if it's one of those humanoid robots and it dances its way 500 meters across the moon, does its video thing, and then sits down on the moon and actually makes a snow angel that the Lunar Reconnaissance Orbiter could see. I mean, it sounds ludicrous, but the fact is we have the technology to do this. And it's my happy little fantasy of what technology is capable of. We just haven't done it yet.
Yeah, the robot, I believe it's Asimo, A-S-I-M-O.
Yeah.
And my favorite time seeing it was on the British show QI, and out there dancing and singing along, and it was wonderful. And having something like that on another body in the cosmos, being able to see what actually happened, see a part of humanity placed onto another part, just like we can see on the moon and on Mars right now, but actually something moving while we're not even there anymore would just be awesome, especially if we can still see remnants of it for centuries to come.
Yeah, it's really cool. Just the ability that we have with the Mars Reconnaissance Orbiters, we can see the different spacecraft that have plowed in different places, and yeah, it's amazing every day what we're capable of. And what I can't wait is, so far in CosmoQuest, we've been showing you moon images, which everyone's seen the moon. There's human beings alive who've walked on the moon. And while it's awesome that these are such high resolution, it's an object that everyone feels kind of familiar with. Well, we have the software done to do a project for the Dawn mission's Vesta orbits. Everything's ready to go. We're simply waiting for NASA headquarters to approve the release of the images. And as soon as NASA headquarters approves the release of the images, we're going to go into beta testing with software that it's going to look very similar to Moon Mappers, but it's going to have a couple extra features. Because one of the things that Vesta has that the moon doesn't have is it has these wrinkle ridges. So for whatever reason, there's these crests and valleys all across Vesta. And so we have a line segment tool to allow you to mark the wrinkle ridges and the bottoms of the valleys on Vesta. And we also have a project coming that's going to be using the Mercury Messenger data. And slowly but surely, we're going to be engaging this awesome community of people in mapping all the rocky worlds in our solar system one at a time as we can get our hands on the data and we can find scientists who want to use the data. Those are our two constraints. We have to have access to the data, and that's the easy one in general. Dawn is an exception because it's a brand new mission. But we only put things live if there is a group of scientists who say, we need the data, we want the data, we will publish the data in a timely manner. So if you're a scientist out there, and there's something you want to do, we want to do it for you so that we can get more people engaged in doing science. So how did all of you first get involved? I'm going to ask you to answer questions while I check on the feeds on the other windows. So Scott, you're smiling broadly. What brought you to CosmoQuest?
Well, I'm always smiling. Come on. Actually, with Frasier and Star Parties is what I was actually fairly new to Google Plus and was really sad there wasn't a science recommendation. So many searches went up for space and astronomy and things like that, and I found him and saw you with your Hangouts and talking over about CosmoQuest, which I'm like, yes, that is awesome. I need to do this now, and I did it for hours the first day. You don't even know, hours mapping the book.
I want to hear things like that. That makes me happy personally.
But it's wonderful for anybody that has a mouse, can literally go through and do actual science anytime they're not playing Angry Birds or anything else. And I've gone onto my campus and I've talked with a lot of the faculty there because it is something awesome that anybody can do. I mean, we see Bridget here right now, and it's awesome that she's getting involved with it. So anybody of any age can do this research. It's not a bunch of white coats in a lab, in a bunker somewhere doing this research. We're all able to participate in it, and it's really exciting. I'm glad you're feeling exactly the way we wanted you to feel. How'd you find us, Thad?
Again, through Fraser. And Universe Today, I think he started following me on Twitter and started following him back, and then tweets about, okay, we're having a hangout, and I haven't even really used even Google Plus before then. It's like, oh, I've, so many other social media distractions. But it's nice. This isn't really a distraction. This is something I can communicate with other astronomy enthusiasts and then bring it to my labs, bring it to my classes. Oh, I was on, and this person posted about this today, and hey, this relates to what we're going on, and we're talking about in lecture this week. So so I saw you tweet about this and figured, well, I actually don't have lab or lecture today, so I'll come hang out.
Cool. Well, I'm really glad you're able to join us. And right now I'm poking through. So for those of you who are just joining us and didn't hear me earlier, if you'd like to be in the Hangout with us, you need to go to the CosmoQuest forums, cosmoquest.org, and either private message me a link to your Google Plus profile, or add it, if you want everyone to know your Google Plus link, add it to the thread Google Plus Hangouts that's under the top section in the forums. It should be obvious. And then I'll use that to give you an invite to get into the forums with us. So there were some questions that I saw on the comment thread. So sorry, while I scroll between different windows. So the first question I saw was from Desi, who said, I know the orbits of the planets around the sun precess. So what that means is looking for, okay, here's something I can turn into. I abuse objects that are on my desk to turn them into science demos. I am sure that whoever made the necklace that I'm about to turn into an orbit would absolutely cry if they saw that this was how I used my jewelry. Okay, so orbits are elliptical. This means they aren't perfect circles. They're slightly squished. And what ends up happening is if you now pretend that our sun is, my microphone is the sun, then over time, this ellipse will rotate around. And so this rotation process, which does not reverse the way it just did when I did it by hand, this movement of the ellipse going around is called, it's the precession of the orbit. Mercury is the one that does this the most noticeably because it's zipping around fast, right up close to the sun, so we notice it the most. So she says, does the orbit of the moon around the Earth precess? Yes, it does. She asks, what's the length of time? I don't know. I highly recommend things like Wikipedia for looking up random numbers. It's wonderful that way, and I learned a long time ago that my brain can hold many things, but it can't hold precise numbers very well. It holds them only for the 24 hours required for an exam. Dad, do you happen to know this?
No, not this one off the top of my head. And I imagine, I mean, there's always the general relativistic effect for, say, the precession of Mercury's orbit, Venus's orbit, Earth's orbit. But then there's also the effect of the other planets on the parameters of the moon's orbit. And yeah, I don't know the general relativistic order of magnitudes off the top of my head. My guess would be something like, for instance, the Venus transit coming up. That would probably have more of an effect on the position of perigee around the Earth than general relativity would be. Don't quote me on that for sure, but I would guess that would have more of an effect.
Now, Bridget, did you actually look up the number?
Yeah, it's 3,233 days, which is just under 9 years.
Okay, so that's pretty impressive. And that precession is the reason that we don't have solar and lunar eclipses the exact same time every year, as well as the precession of the Earth's orbit. So you take both those precessions into account, and that's what's causing all of the eclipses to actually have cycles that change over time. So that's unfortunately the reality of it is everything's in motion. It makes the math really ugly. And one of the things that I personally find really, really amazing is there were folks that were calculating all of these effects by hand, without calculators, without computers, doing their own tables of numbers. And we're getting fairly accurate results. People knew there was something wrong with Mercury's orbit because it was precessing in a way that they couldn't account for when they included all of the known planets. And they did that before we had Excel. I require Excel. I could not have been an astronomer in the days of Newton. It's just truly amazing the mathematical rigor that these people went through to make the discoveries and to generate the science that they generated.
The number crunching alone makes me respect them beyond anything because I love working with numbers and equations. That's why I have a little whiteboard because I hate writing with a pencil doing all those things.
Right.
I still could not imagine doing all of those equations for one small amount of an even larger calculation all the time, and that's all you had to do with it. I couldn't. I would go crazy. I would pull what little hair I have out of my head even more.
Well, there's still a lot of math that if you get a physics or an astronomy degree, it spans pages. And we've all been there. We've all done that to get our degrees. And now we have MathCAD and Maple and MATLAB and all of these different software packages. But at the end of the day, we've all learned how to do things both the hard way and the easy way. I know there was one point where I was calculating the maximum size allowed for a white dwarf before it collapsed into a neutron star. This is a standard homework problem that they give in stellar atmospheres or quantum mechanics. And I forgot a mathematical identity. I just forgot, failed to recognize something, went on for 4 pages of equations because I forgot that one math identity. And what all of the other students in the class, who were admittedly all 3 years older than I was, but what all of the other students in the class remembered was the math identity. So they had this like 10-line long solution, and me, much younger, full of energy, taking stellar atmospheres because I refused to take orgo, and somehow Michigan State let me substitute stellar atmospheres for organic chemistry. I turned in all of my pages and got an answer that was just a few decimal points off of theirs, where I had 3 point calculated a number and they had pi because they recognized the math identity. So there are longer ways and easier ways, and it's worth doing everything by hand so you can make those dumb, dang it, I should have seen that math identity mistake, mock yourself for the rest of your life, but recognize that it's important to learn all of this than to simply rely on the computers throughout your entire life. Eventually you're going to be somewhere trying to figure something out with a colleague. You'll have a brilliant idea in a restaurant. This is where the idea back of the napkin replaces back of the envelope. You'll have an idea in the middle of a restaurant. You'll steal a pen or a pencil from the waitress. You'll be trying to scribble things out, and you need to know the math for yourself. Yeah, have any of you guys ever had a sudden moment of science in a restaurant?
All the time working on my dissertation.
Really?
I mean, it's so consuming. I started carrying just a little pad and pen and paper with me, and things like, what's the density of space needed here to collapse to form a galaxy cluster, and even before that, I guess I was working on helioseismology, and then, okay, well, we're looking at flows of material in the sun. Oh, wait, what if we average over longitudes, or what if we average over oh, hey, this result comes out. So, yeah, it's been less since I've been mainly teaching, but it's something I really stress with my physics students, is learn how to get good at estimates.
Yeah.
Learn how to be able to just rattle off, okay, you like getting out the calculator and writing things out to 8 or 9 decimal places? Stop it. Right? Look at the first 2 numbers, look at the power of 10, play with those, and at least you'll know if you're on the right track for getting an answer, instead of like telling me the speed of light is 10 to the 20th meters per second or something, or that you have the velocity of something in your problem that's going 10 to the 20th meters per second. So, no. Yeah. So,
yeah, I love it when they screw up and they tell you that the velocity of a football kicked at a 45-degree angle is Mach 7.
Yeah.
It's little things like that. So looking over at the feed again, we have Gary Shope, I hope I pronounced that correctly, is doing Moon Mappers along with us. And if you're not doing Moon Mappers, shame on you. You should be logged in and doing science while we talk science. He says that he just pulled up a beautiful boulder field. The image is about 75% boulders and small markable crater in the corner. Beautiful. I get the impression, like many citizens, the moon is a dusty wasteland with occasional craters. Moon Mappers and a garage sale 4.5-inch reflector is changing that impression. And then he goes on to ask, would the boulder field this large be a remnant of a big blast, or is it erosion leftovers, or what? Is the resolution perhaps making it seem larger? So what you're seeing, I know exactly what set of images you're looking at. There's this whole set of sub-images that are going all along a boulder trail, and those are full resolution images. So when you're looking at each pixel in that image of those boulders is about ½ a meter across, so those boulders are a few meters across. So we're talking about SUV-sized boulders. And this boulder field, the way it was created is giant rock from space came, hit the surface of the moon. And when I say giant rock from space, I mean rock big enough that when it hit, it dug into the equivalent of bedrock on the moon and threw boulders up. And you ended up with boulder fields from the stuff that was thrown up when it hit. And what's amazing is you'll get streaks of boulders in different places. You'll also get streaks of what are called secondary craters. And I'm loving learning about all of these things because the secondary craters are very simple to understand. Rock comes in, it will throw up 4 or 5 different rocks in one direction and then others in other directions. And when they land, each of them will have had a slightly different launch angle, launch velocity, starting point. Some variable will be slightly different in how you fire them. And when they land, instead of landing on top of each other, they land in a little tiny row. And you can actually draw lines through these secondary craters and trace back through all the secondary craters to the crater that was the origin of all of them. Now, for the really big impacts, you have to take into consideration the rotation of the moon in order to trace things back correctly. So some of these impacts, you have basically a splatter of boulders sent out, and they hit with such velocity that you end up with all of these subcraters, and they travel so far that the moon has time to rotate before they land, which is just kind of awesome. We see the same thing on Mars. We see the same thing on Mercury. And in the future, secondary craters is going to be one of the big science things that we study in all of the different MAPPERS projects that we're going to be launching over the summer. So what's the coolest thing you guys have seen so far?
I have to pick one.
Yes, pick one.
Yeah. Not specifically with the moon mappers, but I've taken a decent high-res image of the moon earlier this past January and was trying to make it into like a series of movies. And this was on a computer that was woefully lacking the resources to try doing this project. But the bit with finding crater chains and secondary craters and having images kind of stacked and set up in a movie in such a way, the crater chains become very obvious if you have portions of the moon looking like they're moving underneath your field of view. That suddenly, something that looks like a row suddenly just kind of freezes on the screen because you're moving in the same direction that the row is stretched out. So now that I have a slightly better computer and summer's coming up, maybe I'll actually finish that project and look at that with some examples of that, I'd say. So.
That's cool. Now, have you seen anything particularly that caught your attention in moon mappers?
Still, yeah, I'm not too deep into it yet, but I'm sure something will come up here.
Okay. It's a lot of times, most of the images are just the same identical-looking rows of craters. It's when you just randomly discover, oh, wait, that's an Apollo spacecraft in that image, or my favorite so far is I actually found Mickey Mouse, I probably am not allowed to say it was Mickey Mouse, but I found a cartoon-shaped mouse-like structure made out of 3 craters, and that was...
Good save.
I just saw one with it was a normal crater, but there was a massive dark patch off to the left, and I don't know what that was, maybe a lava flow or something.
Yeah, there's all sorts of different albedo features. That's what it's called when it's particularly light or dark, and they're awesome. And I don't understand all of them. I'm working on trying to learn lunar geography. This is a new field for me. I'm a galaxies or variable stars person, depending on if you look at my master's thesis or my dissertation. Geography is something completely different, and geology is worlds away from everything I've done. And planetary geology is really cool, and what's awesome is the differences in gravity just cause such interesting differences in surface changes over time. So yeah. Anything else you guys want to comment on so far?
Differences in gravity and differences in surface composition and history of cooling and all as well. I mean, just for instance, I guess with Mercury and the findings that there's a huge iron core in the middle and likely above the iron core, at least according to the models from Messenger at this point, that mix of iron and iron sulfide, and that it's somewhat softer, and so you don't get quite as large features. If you get large impacts, they tend to settle some more, so you don't get quite the height differences that you have to say on Mars between like the bottom of Valles Marineris and the top of Olympus Mons. The structure itself, the temperature, I guess also like Venus, for instance, being at 900 degrees Fahrenheit all the time, that so many of the silicates are just soft, but yet you still get things like Ishtar Terra and Aphrodite Terra that stand out despite that incredible temperature and softening. So yeah, the gravity plus composition.
Yeah.
Yeah, quite an interesting combination.
And then you also end up with things like, I love the Titan versus Earth, where on Titan you have a complete water cycle of methane. And it's just a matter that the temperatures and the pressures are so low that you're hitting the triple point of methane. And then the composition and the surface gravity of Titan are such that this little tiny low gravity world is able to have the river floodplains, river deltas, that's the word I lost, the river deltas that we see here on Earth, lakes, everything else. It's all of these different fabulous structures that it takes water on the planet Earth and our much more solid surface in order to maintain them on our planet.
I remember watching a documentary about the Huygens probe and showing the landing footage of that, and that it was just so clearly a riverbed.
And what was kind of awesome is when one of the legs hit the surface, it kind of went crunch. It was just like it was crusty surface with less solid underneath, just sort of like that surface of solidified mud that you sometimes end up with on top of the shore of an evaporating pond. And there was recent, after the equinox, Cassini saw some really amazing things in the data where a storm blew up on Titan. And then after the storm passed, there was this whole section of the surface that when looked at, I think they were looking in the infrared, they saw this region that was much darker in most places, but in a few places it was much shinier. And over time, as they continued to watch this area, the surface returned to its normal color, but the places that got darker, they got lighter back to the normal color in a kind of patchy way, just sort of like if you were watching farm fields dry up after the rain, where you have the low spots drying last. But what they'd expected was the shiny spots to change color the way a snowfield does. Where the snow melts, you end up with a dark spot, and then the dark spot lightens back up. But what they saw instead was the shiny parts just went away. And so what they think it was where the shiny parts were, it was some sort of a volatile, some sort of an ice made out of we don't know what. And that ice went straight from solid to gas without ever dampening the soil. So imagine snowfall that simply evaporated without ever creating that terrible mud that at least always follows Illinois snowstorms. So Howard, thank you for joining us. I think you're muted.
Thank you, I'm here.
Okay, now I can hear you. Now I can hear you just fine. So the two questions that I've asked everyone so far are, what are the craziest things that you've heard about the supermoon, and what are your favorite things so far in Moon Mappers?
Well, the craziest things have all been on the news, which way over below everything. I guess what bugs me the most is the people who attribute so much more to what the event is. Like it's the first time it's happened, and that's more evidence that 2012 is going to happen.
Yes.
Well, it's happening right now, actually. The world.
We're allowed to survive 2012,
yeah.
though. And for any of you out there viewing who don't know, there's actually going to be a very nerdy celebration of the world not ending. And a group of us, including Fraser and I, are going to be going on the World's Not Ending cruise out of Miami, and we're going to spend December 20th at Mayan ruins watching the world not be destroyed.
Cool.
So there's tickets available. They're not all that expensive as far as cruises go. It does not cost a cruise line, so it's not going to crash, sink, lose power, anything like that. And so you're all invited. So come watch us. Put on Astronomy Cast live in front of you live. Come watch the world not end. Let's all party together in the Pacific and or Atlantic, I guess is the case may be. So you're all invited. So
I did have a look at
what was that, Bridget?
I did have a look at plane tickets, and they're just way too expensive for me.
Yeah, that's the frustration about some cruises. Is the cruise itself isn't that expensive, but the airplane tickets to get to the cruise are annoying.
Yeah, it's also likely I'll be broke by the time then.
Oh, that's a horrible thing to say.
Well, yeah. Student life, so.
No, this isn't the right economy to be a student, that's certain. So Howard, how did you find CosmoQuest? Was it just through all of the Hangout stuff that we're doing in Google+?
Yeah, and you and Fraser and Phil.
Phil is one of my favorites.
Yeah, I started grinding my own mirror back in 1970 something.
Wow.
With my oldest son, and we never finished it. I still have the 2 blanks, just ready to start doing the final figuring on it. But I've stopped for 45 years, and I'm just getting back to it now. Not that, but to looking up again. So
well, I told you before, Howard. If you want me to come by, since you're close to my campus, I'll come on by and help you with those mirrors. I've got no problem helping you with the telescope.
No, I really don't have an interest in finishing that now. I'm past that point in my life. I'm retired, and I got plenty of other things to do, including the buying of time on the SLU telescopes and the itelescopes.com, which again I got that from Pamela when she mentioned it one night. So I went looking, and I think I just took my 100th image since about late March. So.
And for those of you who aren't following Howard on Google+, you should. He just posted an absolutely stunning image that he took using the SLU system of the Dumbbell Nebula. And let me see if I can figure out how to share it effectively. You're going to all get to see who all I have in circles, I think. Screen share. Let's click that again, and sorry, it's making me select one of the windows I have open, and I'm learning how many windows I have open.
You probably got a dozen open by now. Well, you got it there, so.
I've got it over here for you.
Yeah, I was going to go get it.
Okay.
Yeah, it's a wonderful pitch. Very good.
Yeah, and of course, it's, as I mentioned in the message this morning, there were 2 other gentlemen who were showing theirs that they did on their own private telescopes, and of course it doesn't even compare to this one because this has all been post-processed. But I didn't do it. I'm cheating. I'm buying the time, so it all comes free. I haven't got to that step yet. The one I'm the most proud of is the Owl Nebula, where I caught a meteor.
Oh wow!
A meteor trail. That was really surprising.
That's really cool. And I just learned a very important lesson. If you are magnifying your windows using the command plus, command minus, don't do it to a hangout window. It causes the whole window to just start.
Go screwy, yeah.
Yeah, it looks like it has a bad refresh rate. It just can't quite cope, so don't do that.
I have to say my favorite of Howard's posts is with Gary Ganella's image of the monkey head right next to the monkey head. That was awesome. That was on April 30th, and again,
yeah.
I'll see if I'll share it here.
I went looking for something, and lo and behold, somebody already recognized how hard that was to see, so they had a real monkey head right next to the image, so it was great.
That's fabulous. So for those of you who haven't seen the Monkey Head Nebula, when you first look at it, it's sort of like, huh? What?
Yeah.
But then you rotate it just right, and you're like, wow, that's a tamarin monkey, and you can't deny it once you see it. There's just sort of some things that you can't unsee. And my
well, the more amazing thing is that somebody found a real image of a monkey that looks like the constellation or the image that we're taking a picture of. So it's amazing. You got it, Scott?
I'm pulling it up. It's actually pretty small. I'm going to try to embed it real quick.
I think I might have got it. Hang on.
I have 2 different
there
screens.
It is. Yeah.
There we go.
She's got it.
Oh, you got it? Wonderful.
Yeah.
Yeah, look at that.
I've got something telling me that I don't.
Isn't that great?
Yeah. And now you can also see where I live as well.
Yeah.
But you so totally see. It looks like one of the Planet of the Apes monkeys.
Yeah.
That's.
Well, anyway, I'm having great fun doing this. I put down astronomy for 45 years while I was in the middle of my career, and then when I retired, and really couldn't afford to do this, I'm now doing it. So, well, but I'm not buying equipment. I'm just renting time.
Yeah, and that's the thing that I'm really glad you brought that up. And when you see my eyes going screwy, that's because I'm talking and classifying craters at the same time. Right now, it's possible with all of these different software packages to interact with telescopes all over the world. Peter Lake, who often joins us in our Sunday night virtual star parties, which I think will be starting tomorrow at 11:30 Eastern Time. He lives in Australia, and rather than staying up obnoxiously late as the rest of us would do to be doing our observing, he just rents time on a telescope in New Mexico on the iTelescope system.
It's the same ones that I use, yeah.
And the lowest cost option of all, also the least sexy, but the lowest cost option of all, is if you join the American Association of Variable Star Observers, the AAVSO. It's an organization of professional and amateur astronomers who, for the most part, are studying objects that vary in brightness. So this varies from things like supernova that vary once, very, very radically in brightness, to things like cataclysmic variables that every few months to years to decades will have an eruptive outburst of getting much, much brighter, to the things that I study, pulsating variable stars, which most people consider amazingly boring because they just very methodically get brighter and fainter, and they're Sudoku for a scientist because they often have much more complicated periods than you think of right off the bat, and doing all the Fourier analysis to figure out what they're actually doing, you're not necessarily going to solve any major questions, but you're going to solve that one star. And it's like the most complicated Sudoku puzzle you can ever do. And if you find sweet satisfaction in math puzzles, variable stars are the ultimate math puzzle. And there's an entire professional society dedicated to variable stars. And professional means anyone with a telescope, so that's anyone with a telescope, really. So you, your friends, the people using the 4-meter or the 10-meter professional observatory, we're all working together towards the same goals. Now, where I was starting before I went on this long love affair binge talking about variable stars, for the cost of joining the AAVSO, which last I looked was about $60 a year, you get access to AAVSOnet, which is a network of telescopes scattered all the way around the planet. And you can request time on these telescopes to image different things. You have to give a scientific justification. So they're going to make you do science, but this is Science Saturday, so you should be fine with that. But the fact that you can get access to a global network of telescopes for $60 a year is, I think, the most awesome scientific thing out there for those of you who want your own data. Now, personally, I like to dig in the archives because the archives never get rained on. They're just simply sitting there waiting to be mined. So that's what I do. And right now, I'm controlling the Hangout here. I just found one of those images we were talking about earlier that has boulders in it. So those of you new to Moon Mappers, when you find boulders, there's actually a drop-down menu that lets you mark the boulder field. And what we'll be eventually doing is launching an interface that lets you go in and wherever there's boulders, delineate where the boulder field is and then mark the big boulders within the boulder field. Now, there's an image Scott just put up of the space shuttle. And Scott, why are you showing us the space shuttle? Sorry, easily distracted by shiny spacecraft.
I just sent you a message. I'm going AFK for a second.
Okay, so that's your screensaver.
Well, it's just a bunch of my backgrounds, so I was just putting that up there so you don't see an empty chair for a moment. I feel like pretty things for backdrops instead of empty chairs.
That works. That works. So Thad, what do you do to get data nowadays, or are you on the theory side of things more often?
Let's see. For my dissertation, I was using the Sloan survey.
Uh-huh. You want to explain what that is for people out there listening?
Sure. So in New Mexico, they have a dedicated telescope, 3.5-meter telescope, that it's set up to take shots of a fairly wide portion of the sky and do it in 5 separate photometric bands. So there's one near ultraviolet, one kind of greenish, reddish, infrared, and then farther out in the infrared. And it's basically looking at hundreds of millions of objects, stars in our own galaxy, hundreds of millions of galaxies. The other neat thing it does is that when they find a field of galaxies that have enough bright galaxies, and bright here means magnitude 19, so you're talking something on the order of
Magnitude 19 in the red band takes about 600 seconds, 10 minutes to get good signal to noise on a 30-inch telescope.
Right. So, I mean, essentially it's about a few 100,000 times fainter than what can be seen with the naked eye.
Yeah.
So they'll drill a plate. They'll take a metal plate and drill holes in it where the galaxies come into focus through the telescope and plug fiber optic cables into those holes so that when they re-image this region of the sky, the fiber optics carry light from those galaxies through a spectrometer, and they can take 640 spectra of galaxies at one time. So you have hundreds of millions of objects, a few 100 to 200 million galaxies, and spectra for about 1 million of these objects. So it can be calibrated very well in 3 dimensions. You have your position on the sky, right east to west, north and south, and then from the redshift of the object, how the spectra is shifted due to the expansion of the universe, you can tell how far away the galaxy is. And so my dissertation involved putting together a catalog of clusters of galaxies. And this is the one thing, when you're doing this kind of research, there are certain things you can't think about, or you just go into total, like, oh my God mode.
You go insane, yes.
Yeah, essentially. So I realized, like, about this time of year, at about 9:30 at night, if you have daylight savings time, from the one western horizon to the eastern horizon and covering about a third of the sky that's visible at that time, there are 66,000 clusters of galaxies in that region of the sky. So if you think about what you can see on a dark night, if you can get away from city lights, maybe 3,000 to 6,000 stars. So for every one star that you can see, and this is the region from about 1 billion to about 4 billion light years out, there are 20 times as many clusters of galaxies as there are stars. So not just individual stars, not just individual galaxies, but clusters of 20 or more galaxies. And 20 times as many stars as you can see in the sky, there are galaxy clusters.
And one of the things that I really appreciate listening to this is you give away your academic age, not your physical age, your academic age a little bit by saying that you used the Sloan Digital Sky Survey for your dissertation. Mm-hmm. When I was working on my dissertation, it didn't exist yet. And I was trying very, very hard to do my dissertation on, I was studying what's called the Butcher-Elmler effect, which says that when you look at galaxies nearby, they have less active star formation than when you look at galaxies far, far away that are earlier in the universe. And when you read the literature about this, it's all groups of X-ray astronomers going, that's not there, and groups of optical astronomers going, yes, it is. And when you start piecemealing out the differences in what they're looking at, what you actually find is folks that are looking at the biggest galaxy clusters, those formed early, no star formation ever, basically.
Red and dead.
Red and dead. Then when you look at the little tiny galaxy groups, they're always blue. They haven't had enough interaction going on to kill off star formation. And that explains the group of galaxies we live in. Once all of the galaxies in our group are done self-destructing on other galaxies, a lot of the star formation will be gone. But that's not going to happen for another 5 billion years for us in Andromeda, and everyone else is a little longer to wait. But those intermediate systems, we do see this evolution in color as over time the galaxies interact and they kill each other off. So my goal was to study this in detail, and I was adding a new variable. I was going to be looking at clusters of galaxies that were rich in radio galaxies, trying to define a new way of finding galaxies by using a survey in the 20 centimeter line, 21 centimeter line it was the first survey and the NVSS surveys, using those two surveys to identify galaxy clusters rich in radio sources. Long, drawn-out story. Problem I ran into, my last observing run, 22 nights, of which I got 4 nights. And when I designed my dissertation, the goal was to get spectra of 30 galaxies per cluster and to look at about 30 clusters. I looked at 6 clusters of which I got 3 spectra each. And it wasn't me. It was the telescope. Wouldn't go. And so the fact that we now have these tools that mean you don't have to sacrifice your life to the weather. It means you can go into a project with a great dissertation idea. You know the data exists, and either your theory works or it doesn't. There isn't this option 3 of satellite explodes, telescope doesn't get commissioned on time, and the weather hates you. And I had all 3 of those things happen to me. So I now am a data miner, and I do citizen science programming, and I don't have to worry about clouds. Tonight I was planning to take pictures. It's cloudy. The universe has sent me a message.
This is kind of a two-edged sword, because if you look at the common person out there, they'll look back at what you now can do because the better instrumentation and the satellites, they say, well, you've been lying to us all along. That's one of the problems with the progress in this, any of the sciences. I was in management science. I was in information sciences. And, when a management said, well, here's what we know, and based on what we know, this is how we're going to act, and then it turns out to be different, everybody jumps up and says, you lied to us. Well, I think the real scientists out there today have that problem. There's no question about it.
Yeah, and it's hard to communicate to the layperson the difference between our understanding has changed and evolved to get better, sort of like the mileage that your car can get is better than the mileage a car could get 100 years ago. Cars existed 100 years ago. Their gas mileage sucked. Just like the cars that we have today improve on the technology of the past, but the basic theory is still there.
Yep.
The science we use today is basically the same as the science in the past, but starting to get all grown up. We're starting to fill in details. And what's awesome is occasionally you'll hear people say to kids, oh, by the time you grow up, we'll have figured it all out. I know when I was growing up, I said to people I wanted to be an astronaut, and I was poo-pooed as, oh, you don't want to do that. By the time you're all grown up, we'll have done everything. We'll have completed the space shuttle. We'll have colonies on the moon. There'll be nothing exciting. No, they're still finishing all that stuff up.
Well, my favorite analogy on that is trying to build with wooden blocks so you get a general form of something as opposed to building with Legos, and you can get much more detail. And you're still making the same general structure, but now you're actually have doors and windows and little things. So you have more detail, you have more resolution on what you're doing as opposed to a blob, a spiral nebula. Oh, it's a galaxy, huh? Now we can progress further and figure out what exactly does this mean to us, as humans on this little rock traveling around the sun, around a star. That whole convergence between a spiral nebula and a galaxy just blew our minds and changed all of science just because we're able to look at something a little closer than we could before.
And Howard, I'm going to put you on the spot because you admitted that you were building a telescope with your son in the 1970s, which means you are significantly older than the rest of us.
Oh, yeah, by some.
So what has been your favorite scientific discovery in your lifetime, the thing that sort of made you go, oh wow?
Well, I think because of the industry I was in, I built my first computer back in the 80s, and it's just the speed at which innovation took place. Every 6 months, everything else was obsolete again, and that kind of thing, which is still happening. Miniaturization, all that. That's just the amazing part of it. Now that's all based on science.
Yeah.
All the new discoveries they have, and now they're growing their own crystals from scratch. From the atomic level on up, in order to get even higher speed things. So it's amazing. It's always amazed me.
Yeah, nanoparticles, just the stuff that they're realizing as they go, the potential for what we can do with these things. So on one hand, they're creating amazingly small shaped objects, machining gears, but then on the other hand, they're discovering crazy things like inhaling these nanoparticles is sort of
yeah.
like inhaling asbestos. So
Yep.
we're creating
Yeah.
all new health hazards we'd never
They're
imagined.
starting to use these nanoproducts in things like cold cream and hand soap, and
Yeah.
it's going into your body, at a high speed compared to staying on the first 2 or 3 layers of skin. So there's some real challenges ahead.
Yeah, it's really kind of amazing. Now, for the rest of you, what have been your major wow moments in watching astronomy and space science? And I'm going to look out on the Google group and in the forums to see if there's any more ads or questions out there as well.
Definitely that Titan is sort of like Earth in the way that it has a liquid substance acting as the way water does on Earth. Before that was totally unique to Earth. We'd never seen that before, and just
yeah, that's one of my favorites.
I still remember the day that Huygens landed. I was teaching in an astronomy lab as part of my teaching assistantship at USC, and the books, I think it may have been the cover of the book, had a simulation of what the surface of Titan would look like, artist's rendering, and I was like, your books are all obsolete as of today. Right? That we landed, that picture, that artist rendering, we don't need that anymore. And I don't think I had a projector in the room at the time, but I emailed everybody in my lab the link and said, go look at this. This is what it actually looks like. I think as far as a turning point, though, goes, when I finished my bachelor's, I was thinking practically, if I go into condensed matter physics, then there'll be lots of jobs available, etc. And so I didn't finish my PhD the first time around. I was going for condensed matter, and I didn't have the passion for it like I do for astronomy. And so this would have been stopping in '97 and then starting back up again in 2004. And in that time, you had Perlmutter, Schmidt, and Rees.
That was amazing.
Discover dark energy. And so this wasn't even considered when I was in graduate school before. And then coming back in, it's like, all right, no, I've got to do cosmology. And so I started some stuff in solar physics, but it's like, there's so much more out there. And in my classes this past week, I was showing the PhD comics, where they did the bit on, there's the one on, using the LHC to find the Higgs boson, and there was another one on dark matter, and how 95% of the stuff out there is things we have very little idea about what it is, and kind of not even bringing to with students the idea that every time we answer a question, there are a whole bunch of questions that come from that we couldn't even ask before. But now the biggest questions, they're out there, they're open, and who knows who in whichever one of these classes might be the person to really push the boundary forward. So I think it was a big eye-opener for all of us as to how little we actually knew, and kind of nice to show classes that, yeah, we can talk about a bunch of things that we understand well, but when we get to the biggest questions, there's still a lot to do.
Yeah.
I like the idea that science will always have new questions to ask, and will never sort of stop in any way, I think. That's one of my favorite things, I think.
Well, and at a certain level, it's just amazing that it works. That when Einstein came up with that silly lambda that he threw at the end of his equations for understanding the shape of space, when he threw that stupid variable in there, it was a recognition that you could throw a variable in there, and it was based on the philosophical notion that he thought we lived in a universe that was non-expanding, and by throwing that variable in there, he was able to throw it in with a sign that stopped expansion. And then Hubble discovered, oh, you can explain the fact that most of the galaxies are moving away from us, something that had been discovered earlier, by looking at how fast they're moving as a function of distance and realizing this is an expanding universe. And so suddenly everyone in science had to sit back and think it through and argue, and then everyone accepted it. There was arguing involved, but they accepted it. And then trying to understand why it was expanding. Is it that there's stuff coming back in, and that if you take a cubic meter of space, that it's like you have the universe is injecting that cubic meter of space with new space, and each cubic meter is just somehow growing space? Or is it that the space we have is expanding and getting more dilute over time? This is the steady state versus Big Bang idea. And they're very, very different ideas. And it was from a error in data, people thought, that we've discovered the cosmic microwave background, which was the evidence predicted and necessary to prove the Big Bang. And people, well, first of all, the guys who discovered it tried cleaning their detector to get pitch and coo off of it because they thought the noise that was the sound of the universe, basically forming light, they thought that was an error. Then they realized it, and people accepted it.
And what's amazing is they saw that all along on the television. All along it's been there, but we just weren't looking.
Yeah.
And it shows if you can take the time to look specifically and you actually can focus on something, you will find something. It might not be what you're looking for, but that's what's awesome about science, is that you might fail, but in your failure, there are 9 triumphs that could come from it.
And what's awesome is when people find something that no one expected. Like I for one, was extraordinarily sad when they found dark energy, because the math for the research I was doing at the time suddenly became much, much harder. And there was actually one day where trying to solve an equation and making the mistake, it's like you're sitting there going, I'm either going to cry or solve this, or maybe both, but I'm definitely going to eat junk food. That's the only way you get through your math sometimes. And thankfully, there's this fabulous cosmologist by the name of Ned Wright. He programmed a digital JavaScript calculator that has solved the need to calculate all of this for all of us. We just all go use his calculator, Ned Wright. Thank you.
He's at UCLA, right?
He's at UCLA. So many kudos for this man for putting online such a simple and fabulous tool that saves all of us from crying over the cosmological constants, because it makes the equations hell. Mercury and Venus both have friendly surfaces compared to trying to solve these equations. But we keep accepting these changes. We keep advancing our understanding. We argue, we dig our heels in, and then we get over it, and we realize the universe isn't what we thought it was. It's actually way more interesting, and it works.
Actually, I guess we have 2 things to thank Ned Wright for. The calculator, if I remember correctly, he's also Neil deGrasse Tyson's advisor, PhD advisor.
Really?
Yeah.
I did not know that. That is very random. Okay. I thought Neil had worked on Supernova for some reason. So.
I'm pretty sure I remember going to a colloquium at USC where Ned was giving the talk, and that was one of the little factoids before the talk.
Okay, one of you folks out there listening needs to Google this and let us know. So actually, looking out at the comments in the feed, Mike Richter's out there, or Rector's out there, rather. Sorry for mispronouncing your name. I do know better. He says he wants to join us on the cruise. Yes, join us. Bring your telescope. It would be awesome. That might not fit in the overhead bin, though. He's mentioning that there's actually a variable star app for your iPhone, iPod, iPad, choose your iDevice, and that it comes with a lot of different info to read, tells you about all the different types of variable stars. He has yet to use it, but he's going to plug it anyways. But he's gotten it for when he has his moments of variable star addiction feeding. So those of you who are interested in, go ahead and join us. And he also said that in Moon Mappers, he periodically comes across craters that look like mountains, and he's not sure if he should mark it just in case. So the issue is there are giant craters on the Moon that when you look at their degraded walls, they really look like circular mountain ranges. At the scales of the images that we're looking at, you're just looking at a really jagged crater. And there's actually at least one area where there's a crater that's so big, it spans across, I want to say, 9 different images. So when you're looking at the center images, it's just black crater floor basically. So there's one giant crater in moon mappers, and you'll only see part of the crater wall in any one given image, and it really does look like a mountain range. But no, that's just what happens when a really big asteroid decides to take a chunk out of the moon. And one of the awesome things about the gravity being so little on the moon is craters can get really, really deep and have their edges not completely cave in on them. Here on Earth, if you tried to build a steep-walled giant hole anywhere that wasn't solid granite or some of the other substances that they've mined into, you're going to run into a problem with all the soil collapsing in. We actually have a limit on how tall mountains can get on the planet Earth, because eventually gravity tries to return them to being more even with sea level like everything else. And so gravity causes things to cave in and flatten out. When you don't have as much gravity on the moon, when an impact happens, you can end up with these extremely steep-walled craters that just don't cave themselves in the same way. There is still slumping. It's just not the same slumping you get on a high-gravity world like Earth. So if there's any more questions, I'll go ahead and take them. And unfortunately, our supermoon here is clouded out at the moment. I'm going to have to wait for it to get above the haze outside, which is making me sad.
Is there a forecast for any clearing at any point tonight there? Or?
It's the typical spring in the Midwest, 30% thunderstorms throughout the night. And what ends up happening is you end up with this layer of haze, so when you look down towards the horizon, there's no defined clouds, you just can't see your horizon. Once the moon gets straight overhead, assuming there aren't thunderstorms straight overhead, we'll be able to see it straight overhead. But I had this goal. It was a goal, a good goal, of going out to the farm where I keep my horse, and there's this fabulous cornfield, and the corn is this tall right now. It's quite cute. And out at the horizon point, exactly where the moon would have been rising, is this big old red barn. And at the distance I would have been, the moon and the red barn are about the same size. And I couldn't quite figure out exactly where it would be rising, but I figured I could move my tripod around and get it so that the moon was right next to the barn. And that was my goal, and my goal was foiled. But there'll be another full moon, another month. It's just I have to worry about eventually the corn gets tall enough you can't see the barn in the distance. But it's big.
Speaking of, actually this goes back to 2 topics we were just talking about. One is the slumping of craters, and how the crater walls can be a good bit more stable without having as much gravity around. So one of my present to myself after I finished my PhD was to get a Schmidt-Cassegrain scope. I'd been drooling over these things since I was 10 years old, and so it was like, okay, this is it. This is a big event. I'm rewarding myself, yeah. And so I was out shooting the moon, just kind of scanning along the terminator, the break between daylight and darkness on the moon. And I'm going to see if I can screen share this shot that shows kind of craters built into the walls of craters. So let's see.
This is me looking at my other screen. Oh, so that's beautiful.
Wow.
So that was, yeah, so this is from a movie, what was I shooting? Something like, 30 frames a second, and there's still some of the signal that's in there, but just how rugged that is, and it kind of runs right down the middle of the face of the moon that faces us. So this is kind of right below. I think it's kind of between Tycho and I think it's Mare Vaporum above it.
Yeah.
And this is just part of the chain that's in there, and just being able to see kind of the layering of crater upon crater upon crater. And yeah, the lighting was just right. So I mean, it's a serendipitous find, but yeah, I was very happy to.
Well, what I love about the crater in the top left of that is that's what's called a terraced crater, and we actually in moon mappers have an option for when you find those. There's a flag that you can mark them, And those are places, from what I understand, that when the asteroid hit the surface was two different densities. So you have a band of one density and then a band of harder stuff. And it dug through the softer stuff to the harder stuff. And this is where you see the two different types of slumping occurring within the wall of the crater, creating that terracing that you sometimes see. And that's actually really scientifically interesting when we find those terraced craters. And you just got a fabulous image of an example of one there.
Thank you.
I think I remember seeing that one in one of the first star parties you did.
Yeah, we're always trying to do star parties at the time of month when you see that quarter phase moon that demonstrates all those beautiful regions. Yeah, it's really awesome. Now, David, with the images, is David still here?
Yeah.
Okay, sorry. I had a window on top of you, and I just wanted to make sure I wasn't talking to someone not here. Make sure I was, yeah, I had that. Double negative was correct that time. With your, you said you have a 800 millimeter telephoto lens, or was it 900?
Yeah, that's my biggest one.
So how big is the moon in your field of view? You're looking at like a third of the moon?
Yeah, about a third, maybe a little less, depending on how full it is. It's an extra 12% tonight, so maybe a little better.
Yes. Extra zoom factor brought to you by Orbital Mechanics. So with a lens that big, you're really dealing with a telescope attached to the body of a camera. Do you have to mount the lens to the tripod at that point?
Those lenses, yeah, you actually mount the lens to the tripod.
And do you have a tripod that tracks or anything like that, or are you just taking really short exposures?
It does not track, so yeah, I do short exposures and then software that does quasi-lucky imaging with those exposures.
So you are spending a lot of time chasing things by hand on your tripod, it sounds like.
Depending on how far I zoom in. I mean, if I leave it with a wider field of view and just abuse 20 megapixels, you let it track for a while and then move it.
Have you ever gone on to image things like Mars with that system?
I have not done much of the planetary stuff. No, mostly I've been trying to focus on nebula and really trying to stretch, see how far I can stretch using just a camera.
What exposure length can you do without tracking?
Usually I do about 5 seconds and then stack those up.
Okay, so you're looking at really, really big nebula then.
It depends on where I am. In some of the southern Arizona areas, I mean, the visibility, there's no light pollution. If you get into some of the better mountains, I mean, you can do, even with very short exposures, you can get pretty good lighting on them.
Well, I was thinking more a matter of if you zoomed in too far to get some of the tiny ones, you'd be affected much more by stellar motions than if you're zoomed out for the ones that are not necessarily brighter, but physically bigger on the sky.
Yeah, it depends on what I'm trying to go after at that. If they're smaller and I have to zoom in, it's a lot harder to track even with the lucky imaging. Unfortunately, I spent so much on the camera and the lenses that getting a tracking mount for it is a couple months away at least.
Yeah, that's one of the hard things, is just trying to figure out what order to spend your money in. Now, I decided to go left and bought a horse. Yeah. and part of the reason behind that was the horse was actually cheaper than the telescope I wanted. And the thing that got me in trouble is I got to borrow a TeleVue Pronto telescope with really nice Nagler zooming eyepieces. And yeah, it was an expensive, awesome system that I was able to borrow for about a year. And after borrowing that system, which is small and light enough that you can easily stick it in an overhead bin while you're traveling, I was like, okay, so for research, I'm using data that I can download. I'm using professional systems. It's all good. But for just going out and looking, I wanted one of these high contrast refracting systems. And to buy that system, plus buy the eyepieces I wanted, plus get a really nice tripod that was both lightweight and could track, I was looking at $5,000 basically by the time I was done. And suddenly the horse seemed much more affordable. And all of you wonderful people out there with telescopes that join us in the star parties, I live vicariously through all of you. So I'm looking at you, Mike. I'm looking at you, Gary, if you're out there watching as well. Corey, all of you guys, you make it so that I don't need to figure out how to afford the telescope that I really want. Although I have to admit, I keep seeing these fabulous images of the moon all zoomed in on the horizon, of constellations all zoomed in on the horizon. And I'm thinking I'm probably going to give in and get a 300 millimeter lens at some point. But that's where I'm going to call it quits, is a 300 millimeter lens. At least this is what I'm telling myself.
I've been meaning to try doing one of the hangouts where we're observing, but from here in LA, from at least from in front of where I live, sometimes get a little bit of a interference, and I just want to share the one photo where I was taking a pretty good shot of the moon, 6 different frames, but LAX's landing path is pretty much cuts across the part of the sky where the ecliptic is. So the one time, the one shot I got in a series of about 100 shots of this portion of the moon had a bit of an interloper here.
What is that?
That's a jet with its engine?
That is the engine on, well, I guess it's probably a 737. It has two engines, one on each wing.
Dang.
So, yeah, so just snapping at about like one picture every 2 seconds, that came through on one of them. So
that's the side of the plane along
Yes.
the left edge of the frame, the notch to the wing, and then the engine hanging. That's crazy.
Yeah. So, it'd be something if I knew I could get enough of a signal from the sidewalk. I mean, of course, yeah, there's all the light pollution in LA, but every once in a while something like that happening too. So
That's absolutely wild.
Yeah, I'm not too happy with their light pollution out here in LA. It's not fun at all.
Well, there's one thing to say you have light pollution, to say you have plane pollution. It's a completely different problem. I actually ran into this problem as well, and I'll see if I can share one of the images. I was trying to get some nice images of Orion, of just that whole region of the sky when we had Venus and Jupiter at conjunction a couple months ago. And I managed to get this whole series of basically planes going through the field of view, and it made me really sad because I wanted something that I could use to show the historic view of what it looked. No, there's airplanes there. So yeah, we're underneath the landing path for St. Louis Airport, and then there's 2 other regional airports. So I'm just kind of stuck. Fairly dark, too many planes.
and one thing I do love about living out here, though, is it's only a 2.5, 3-hour drive to some place that is spectacularly dark.
Oh,
So,
where do you go?
Usually out by Joshua Tree.
Okay.
Yeah, Joshua Tree is great. I love going out there.
What's the altitude there?
About 3,000 feet, 4,000 feet.
Okay, so that's perfectly reasonable.
Yeah. And then, if you want to drive about twice as far, there's Death Valley. So, and I got to spend winter solstice this past year in Death Valley, and that was so worth it. The other thing is, I mean, typically you think, okay, you're imaging on winter solstice, you're going to be freezing, but this is at sea level, and occasionally a breeze would blow through. It was like 70 Fahrenheit. I'm out there at 3 a.m., and there's this warm breeze blowing off the desert, and you just have this amazing winter sky above you there. So that's got to be one of my favorites. The only time I've seen the zodiacal light in the United States was that night as well. So,
Oh, wow.
yeah.
I've only seen the zodiacal light once, and it was when I was at a professional observatory at an extraordinarily dark site. It's just not a common thing to get to see.
So just for, I guess, people watching the zodiacal, this is the
Yeah.
one thing, learning in a vacuum sometimes you don't get pronunciations right. But so the zodiacal light is essentially it's dust left over from the formation of the solar system and from collisions between asteroids. And it lies along the ecliptic. And so if your sun blazes dark enough, it shows up really well. And the best observations I had of this, my brother is in the Peace Corps in Botswana. And so we went to visit him last summer. And he kept saying, well, you may not be able to see the stars very well because there's the soccer stadium that's a mile to the west of us. And so, I go out the first night we're there, and I look, and it's like, the soccer stadium's not lit up. What's he talking about? It's the zodiacal light.
Wow.
It's so bright, it looks like it would be coming from a stadium being lit up. And that was unbelievable. I still dream about being there. I've got some shots. I couldn't bring a telescope, but I borrowed his TI-1 Canon Rebel when I was over there and bought a little tripod to bring with me and just, set up and shot away anytime I could. So
that's absolutely amazing. So I'm cheating and I'm using 2 different computers, which is how I've been showing moon mappers all evening. But I'm going to break away from showing moon mappers, and all of you out there watching should be mapping the moon along with us. But what I'm showing now, and then you switch screens using this computer, this is one of a series of images I took with Orion off to the left, dead center, an airplane. It just felt like going through, flashing its little red and white light as it went. And then Venus and Jupiter off to the lower right, and then you can see Pleiades also middle right. And then there's the plane continuing to go through. In comes another airplane. There goes those 2 airplanes. And that's my horse, end of sequence. But it was just one of those, I set my camera to do a whole sequence. I got this one zoomed in that was fine, but then when I zoomed out to get the planets, I set it to do a sequence of 4 images. And all 4 of them, just airplane, 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 airplane. And yeah, I was annoyed, and I just didn't notice them while I was taking the photos. And when you're looking on the back of your camera, that didn't show up. So it was, when I got home, I was like, curse you. But airplanes happen. It's the realities of our modern age. So we've been doing this for about an hour and a half now. And my husband just came in and looked very sad into the room, hiding where no one could see him. And normally sad husband equates, I'm hungry for dinner. So we should have a supermoon rising on our horizon right now. I can't see it from inside the house due to the haze. I'm actually going to try going up on my roof, seeing how bad it is from the roof. Trying to get a couple more photos, and then in about an hour from now, I'll probably start up another hangout for anyone who wants to join. For those of you out there listening who want to join in and be in the room, this is a CosmoQuest members only inside the hangout, so you have to go to cosmoquest.org, register, and send me through private message or leave in the forum threads a link to your profile. I will add you to a CosmoQuest members circle in my Google Plus account, and I will invite you in when I start this back up. If the weather's clear, it'll be more than an hour, so I beg your forgiveness. I need to get my camera going and try my own attempts at getting some photos. So it's been wonderful having all of you with me this evening. We have Brigitte, David, Howard, Scott, and Thad, who has the most awesome name ever. And thanks for talking the moon and astronomy and everything else. And it's been great. And for all of you out there, go do moon mappers. Turn this into a supermoon science Saturday. And we're going to extend our Million Crater Challenge for at least 24 more hours due to the fact that the servers kept blowing up. We had a CPU failure. It took me forever to figure out what was going wrong. The first time our server fell over, I looked at the server logs, and it was like we had all sorts of memory rewrites going on, crash. So I thought it was an out-of-memory error. Second time it went down, couldn't figure out what the heck happened. Third time it went down, it looked like it was due to someone downloading a bunch of stuff. Dug further. Each and every single one of them had this mysterious Linux CPU error I'd never seen before that very rarely, but it appears to be this time, is due to a CPU dying. And we're on a brand new server as of about 2 hours ago, and the brand new server seems to be staying up. I'm certain that as soon as I go to sleep it will crash, but here's to hoping that it stays up. So thanks all of you for joining me, and as I said, I will be back in an hour unless the weather is perfect, in which case it will be more than an hour. So,
thanks, Pamela. Good luck with your shots tonight.
Thank
Clear
you.
Good luck.
Have a great evening, you all. Bye-bye.
Bye.
Yeah.